So step one is to determine the null and alternative hypotheses. Step 2 is to choose the level of significance, alpha. Step 3 is to compute the test statistic. Step 4 is to find the p-value and determine the initial conclusion. And step 5 is to state the final conclusion. And these steps are the same no matter what type of hypothesis test we're doing. So in order to do a hypothesis test, we first have to have a claim or a statement that's being made. So the first step in finding the null and alternative hypotheses is to write down this claim as a complete sentence. Then we're going to take that claim or statement and translate it into an alternative hypothesis by answering these questions. The first question is, what parameter is being tested? In this chapter, it's either going to be a mean, which we represent with mu, or a proportion, which we represent with p. Next question is, what inequality should be used? For our alternative hypothesis, it has to be either less than, greater than, or not equal to. There cannot be an equal in any of these three. And finally, what's the value of the parameter stated in the claim? The value used in our hypotheses never comes from the sample data. It always comes from the claim. Once we've answered those three questions, then we can translate the answers to those into our alternative hypothesis, H1, in symbols. Once we have the alternative hypothesis, then we can write the null hypothesis just by replacing the inequality in our alternative hypothesis with an equal sign. In 2008, 62% of American adults regularly volunteered their time for charity work. The politician claims that this percentage is different today. So first, again, we'll write our claim as a complete sentence. That is, the percentage of Americans who regularly volunteer their time for charity work is different than 62%. Again, it's important to write enough in this claim so that you know what we were talking about in the beginning. So you need to include what our percentage is measuring in this case, and that is the percentage of Americans who regularly volunteer their time for charity work, because we'll use this information later on in our hypothesis test. You also need to include wording that will allow you to talk about a proportion or a mean, and you need to include the value that's listed in the claim. Now we're going to translate this into our alternative hypothesis. So first, what parameter are we testing? Since we're talking about a percentage, that's the same as a proportion, and the notation we use for that is p. What inequality should be used? Different translates to a not equal to. And what's the value of the parameter in the claim? 62%. We're going to convert this to decimal, so we'll have 0.62. So our alternative hypothesis will be H1 is that p is not equal to 0.62. To get our null hypothesis, we just replace that not equal to with an equal to. So our alternative hypothesis is that p is not equal to 0.62. Our null hypothesis is that p is equal to 0.62. So to do this, let's go back to our jury story and think about the outcomes of our trial in terms of the actual truth versus the verdict that we come up with. There are actually 4 different possibilities for the combinations of these two. So here's our truth here and our 2 possible verdicts over here. So if the truth is that the defendant is not guilty and we come up with a verdict of not guilty, then we have the correct verdict. If the truth is that they're not guilty and we come up with a guilty verdict, then we have an incorrect verdict, and this is the most serious type of error. This would mean that we're convicting someone who's actually innocent. So this is the one that we want to avoid most of all. Now, if the defendant actually is guilty and we find them not guilty, then we have an incorrect verdict. And again, this error is not considered as serious as this one up here. Finally, if they are guilty and we find them guilty, then we have a correct verdict. Now, how does this relate to hypothesis test results? Well, here, instead of truth versus a verdict, we have the truth, or the true value of the population parameter, versus our test conclusion. There are two possibilities for the truth. Either the null hypothesis is true, or the alternative hypothesis is true. And we have two possible test conclusions, either do not reject the null hypothesis, or to reject the null hypothesis. So this would be like not guilty and guilty. So if the null hypothesis is true and our conclusion is do not reject the null hypothesis, then we came to the correct conclusion with our test. If the null hypothesis is true, but our conclusion is to reject it, then we have an incorrect conclusion, and this is a type 1 error. And this is the most serious type of error. This is the one that we really want to avoid. Just like we would want to avoid on our jury convicting someone who's innocent. Now, if our alternative hypothesis is actually true, then if we have the conclusion that we don't reject the null hypothesis, that's an incorrect conclusion, and that's called a type 2 error. This error is not considered nearly as serious as a type 1 error. Finally, if our alternative hypothesis is true, and our conclusion is to reject the null hypothesis, then we have come to the correct conclusion. So when we're designing a study and determining what we want our significance level to be, our significance level is going to depend on the consequences of a type 1 error and how serious those consequences are. For example, if we're doing some type of drug testing where the consequences of this type of incorrect conclusion could be very serious, could be a serious safety risk or something like that, then we want the probability of making this error to be extremely small. So we would make our significance level very small, like maybe 1% or even less than that. Sometimes it's more like 0.1%. On the other hand, if we're doing research and collecting sample data just for information purposes, then the consequences of making this type of error would not be as serious. So in that case, we could afford to make our significance level a little larger. In some cases, we might go as high as 10% with our significance level. So the significance level alpha is the probability of a type 1 error. Alpha should be determined during the design stage of a study before we collect the sample data. And to determine alpha, we consider how serious the consequences of a type 1 error would be. The more serious the consequences, the smaller our value of alpha should be. And some typical values for alpha are 10%, 5%, and 1%. Here's another example. And this is from the example about adults who volunteer for charity work. We came up with our two hypotheses. So again, type 1 error is rejecting the null hypothesis when the null hypothesis is true. This would mean concluding that the true percentage of Americans who volunteer for charity work is different than 62% when it really isn't. So again, it's like accepting the alternative hypothesis when the null hypothesis is the true one. Type 2 is the opposite. This would be accepting the null hypothesis when the alternative hypothesis is actually true. And that would mean concluding that the true percentage is not different than 62% when it really is different than 62%.